Hello friends, welcome to Engineering Funda family. In this video, I'll be going to explain you few very interesting questions based on calculation of memory when you interface memory chips with computer. Here, I'll be increasing complexity of questions compared to previous questions. Let us see first question over here. So if you observe, here we have been given with 64K cross 2 RAM chip. So these are the chips that is available, and question is how many chips required to build 128 KB of RAM. So this is what we wanted to have. Also calculate the size of decoder. So you see here available chip is 64K cross 2 and we need to build 128 KB of RAM. So how many chips required? Total size divided by available size. So total size is 128 KB and available size, that is 64K cross 2. Now we need to calculate this. So 128 means what? 2 to the power 7, K means 2 to the power 10, B means 8 bits, so you can say 2 to the power 3, divided by 64 means 2 to the power 6, K means 2 to the power 10, and cross 2 is there, so that is 2 to the power 1. So in numerator we have 7, 10 and 3 means 2 to the power 20, and in denominator we have 6, 10 and 1 means 2 to the power 17. So we have 2 to the power 3 means in total 8 chips needed to have this size of RAM using these chips. Now previously if you see my questions in which we were been calculating decoder size, right? In that if you observe, we have seen size of data that was same. Here you see required size is having size of data, that is B means 8 bits, and here also available size is having data, that is 8. So in that directly we can say number of chips is equals to output of decoder, right? But here if you observe question, then in this you see required chip is having number of data lines, that is B means 8 bits. But here available RAM chips that is having data, that is 2 only. So how to identify that? So for that you need to have horizontal expansion as well. Let me explain you this by drawing first. After that I'll explain you how we can use the formula. So here we are having available chip, that is 64K cross 2. Let me draw that first once. So when you talk about 64K cross 2, what it means? We are having number of addresses, that is 64K. So how many addresses are there? 64 means 2 to the power 6, K means 2 to the power 10, means 16 addresses will be there. So here number of address lines, that will be A0 to A15, means in total 16 addresses will be there, right? And how many data lines are there? 2 data lines are there, right? Similarly, how many chips are there? 8 chips are there. Now you see here how many data lines that is required in this chip. We are having requirement of 8 bits, B means 8 bits. So horizontally we need to have 4 RAMs so that you can have total 8 data lines. With single RAM we have 2 data lines available, right? So in total 4 RAM chips that we need to connect horizontally. Let me show you first. So you see I am connecting 4 RAMs horizontally so that we can have in total 8 data lines. Here we have D0, D1, then we will be having D2, D3, then we will be having D4, D5, then we will be having D6, D7. So what will happen with the combination of these 4 chips? We will be having total address lines, that is 64K, and by having 8 data lines you can say 64 cross 8 in total size is there with the use of these 4 chips, right? In total we have 8 chips to make this size. So vertically we will be having another this 4 RAM chips connection will be there. So you see this 4 chips that is making 64 KB and this 4 chips that is making 64 KB. In total 128 KB is there, right? Now when you talk about decoder size, then only one line that will be decoding all 4 chips together, right? As we need to have 8 bits of data. So here when you have decoder, at that time one line of decoder that will be decoding upper 4 chips. Let me show you how it will be decoding all those chips. And second line of this decoder that will decode lower 4 chips. So only 2 lines that you need to have to select those chips. So you will be having select over here as per 2 lines only. So output will be 2 only. So obviously input will be 1 only, right? So one input that will be selecting 2 outputs in decoder over here, right? And this line that should be address line only. You see 128 KB, that is the size which is required. So how many address lines that should be there? 128 means 2 to the power 7, K means 2 to the power 10. So in total 2 to the power 17 means 17 address lines will be there. So A0 to A15 means 16 address lines that we have used it with all the chips, and A16 that we will be using for decoder. So the size of decoder over here that will be 1 cross 2 only. Now I am going to explain you how this calculation that we can have without drawing diagram. So when you want to have decoder output, then decoder output will be number of chips into available data line divided by required data lines. This is how we can calculate decoder output. You see number of chips that is 8. So let us substitute 8 over here. Available data lines that is 2 only, right? So here into 2 divided by required data lines. Required data lines are 8 only, right? So how many outputs that will be there with decoder? You see 8 divided by 8 into 2, that will be 2, right? So this is how outputs that we can find for decoder, and based on output directly you can identify what will be the size of decoder. Let us have one more question similar to this. So in second question you see 16K cross 4 RAM chips that is given, right? How many chips required to build 64 KB of RAM? So here required size of RAM that is 64 KB and available is 16K cross 4. Also we are deal with to find size of decoder. So first of all we need to identify number of chips, that is total size of memory divided by available size of memory. Total size is 64 KB and available size that is 16K cross 4. So here if you observe 64 means 2 to the power 6, K means 2 to the power 10, B means 2 to the power 3 divided by 16 means 2 to the power 4, K means 2 to the power 10, cross 4 means 2 to the power 2. So in numerator we will be having 6 plus 10 plus 3 means 2 to the power 19, and in denominator we are having 4 plus 10 plus 2, 16. So 2 to the power 3, that is 8 number of chips that we need to have to build 64 KB of RAM using 16K cross 4 number of RAM chips, right? Now my dear students, question is to calculate decoder size. So here I am not going to show you how circuit is there. I will explain you how we can identify decoder output. So decoder output will be number of chips into available data lines divided by required data lines, that is 8. So how many number of chips are there? 8 number of chips are there. How many available data lines are there? You see 4 data lines are available, right? So 4 divided by required data lines, that is B. B means 8. So in total 4 outputs will be there with decoder. Now once you have idea about how many outputs are there, you should know decoder will be there as per input cross output. Output is 4 over here, and you should know outputs are 2 to the power n and inputs will be n. So 2 to the power 2, that will be 4. So you can say n is 2 over here. So our size of decoder, that will be 2 cross 4, right? So my dear students, that is how we can identify size of decoder even if you have different size of data lines. Still, if anything that you would like to share it with me, please write down in comment box. I'll be happy to help you. Thank you so much for watching this video.